Hello friends, myself R.D. Mahajan presenting my video on MCQs on Laplace transform. Part 1. First question, Laplace of e raised to 3t is equals to. Out of that 4 options we have to select a correct option, and for that we know that Laplace transform of e raised to at as 1 upon s minus a, and therefore Laplace transform of e raised to 3t, comparing this with that standard result, here we have a is equal to 3, and therefore substituting that value as a as 3 here, we get 1 upon s minus 3 as the answer, that is option B is the required answer. Very simple. All the questions are based on the basic results or basic concepts of Laplace transform or standard result. Second example, find Laplace transform of sine of 40. Select the correct option out of that 4. And to find answer for this, we know that Laplace transform of sine of 80 as a divided by a square plus a square, a standard result for the Laplace transform, and therefore applying this we get Laplace transform of sine of 40. Compare and get the result. Therefore comparing these two, we get the value of a as 4, therefore it becomes 4 divided by a square plus 4 square as the required answer, that is option C from that option. Example number 3rd, find Laplace transform of sine h 2t, sine hyperbolic of 2t, and to find correct option we know that Laplace transform of sine hyperbolic at as a upon a square minus a square provided s greater than a standard result from Laplace transform, and therefore applying this result we get Laplace transform of sine h 2t. Comparing we get here a as 2, therefore it is 2 upon a square minus 2 square provided s greater than 2. As the answer, option A out of that 4 option as the required answer or the example number 4, find Laplace transform of cos of 5t, and to find that correct option we know that again standard result, Laplace of cos of 80 as s upon a square plus a square, and therefore Laplace transform of cos of 5t as here it is s upon a square plus 5 square as the required answer. Option D is the fifth example, find Laplace transform of cos hyperbolic of kt. And to find the correct option, we take the help of the result. We know that Laplace transform of cos h at as s upon s square minus a square, provided s greater than a. And therefore, Laplace transform of cos h kt as s upon s square minus a square. Comparing, we get the value of a as k here, and therefore it is s square minus k square, provided s greater than k. As the answer, option C as the required answer. Example number 6, find Laplace transform of t square. And to find the correct option, again we take the help of the standard result. We know that Laplace transform of t raised to n, when that n is positive integer, it is n factorial divided by s raised to n plus 1. If n is positive integer, if n is positive integer, here the value of n is 2, positive integer, and therefore Laplace transform of t square is equals to, the value of n is here 2, therefore it is 2 factorial divided by s raised to 2 plus 1. 2 plus 1 we get s raised to 3, and therefore its value is 2 factorial is 2 divided by s cube as the required. Option B as the right answer, or the correct option. Example number 7, find Laplace transform of t raised to 3 by 2 as. I'll select the correct option out of that 4. And to find that, we know that Laplace transform of t raised to n, if it is not positive integer, its value is given by gamma n plus 1 divided by s raised to n plus 1. If it is not positive integer, and therefore Laplace transform of t raised to 3 by 2 as gamma of n plus 1, the value of n is here 3 by 2, divided by s raised to 3 by 2 plus 1. 3 by 2 plus 1 we get 5 by 2. We know that result from gamma function, gamma n plus 1 is n gamma n, and therefore this gamma 3 by 2 plus 1 I can rewrite as 3 by 2 gamma of 3 by 2 divided by s raised to 5 by 2. It is equals to, once again we write 3 by 2 as n plus 1 form, in the n plus 1 form. Therefore it is 3 by 2 gamma 3 by 2 we can write down as 1 by 2 plus 1 divided by s raised to 5 by 2, and that is equals to, once again applying the same result, we get it is 3 by 2, n is here 1 by 2, means n gamma 1 by 2 and whole divided by s raised to 5 by 2, and therefore it is 3 into 1 we get 3, 2 to the 4. We know that the value of gamma 1 by 2, standard result from gamma function, as root pi, and therefore it is root pi divided by s raised to 5 by 2 as the answer. 3 by 4 root pi divided by s raised to 5. Option B is the example number 8, find Laplace of e raised to at into sine of bt. Here it is the problem of first shifting theorem, as that function f of t is multiplied by e raised to at. Therefore, by first shifting theorem, if Laplace transform of f of t as f bar of s given or we can obtain it, then Laplace transform of e raised to at into f of t as 1 upon replacing s by s minus a, and therefore it becomes f bar of s minus a. This is the statement of that first shifting theorem, and here we have Laplace of sine of bt. Applying standard result of Laplace transform of sine of at, it is a, here a means b, s square plus a square b square, and we call this as f bar of s. Okay, and therefore by first shifting theorem, Laplace of e raised to at into sine of bt as replacing s by, when it is plus 80 we have to replace s by s minus a, and if it is minus we have to replace s by s plus a, and therefore replacing s by s minus a, we get, therefore replacing everywhere s by s minus a, we get b upon s minus a whole square plus b square as the required answer. Option D as the correct answer. Example number 9. Laplace of e raised to minus 2t into cos of 7t. Again, it is a problem of first shifting theorem, as that f of t is multiplied by e raised to minus 80 type of term. Therefore, once again by first shifting theorem, if Laplace of f of t is f bar of s given or we can obtain it, then by first shifting theorem, Laplace of e raised to minus 80 into f of t as f bar of s plus e, replace s by s plus e, and therefore here we have Laplace of cos of 7t s upon s square plus a square 7 square. We call this as f bar of s, and therefore by first shifting theorem, Laplace of e raised to minus 2t into cos of 7t as replacing s by s plus a is here 2, and therefore replacing s by s plus 2, we get, that is equals to, everywhere replace s by s plus 2, in that result we get s plus 2 s plus 2 whole square plus 7 square as the required. Option C is the required answer or right answer. The last example, example number 10. Find Laplace of e raised to at into t cube. Once again, a problem of first shifting theorem, as that f of t is multiplied by e raised to at term, and therefore by first shifting theorem we have, if Laplace of f of t as f bar of s, then Laplace transform of f of t multiplied by that e raised to at is f bar of s minus a. replacing s by s minus a. And here we have Laplace transform of t cube, t raised to n, with n as 3 positive integer, and therefore as per that formula it is n factorial 3 factorial divided by 3 plus 1, we get ss to 4. It is 6 upon ss to 4. We call this as f bar of s. Say. Then by first shifting theorem, Laplace transform of e raised to at into t cube is equals to replacing s by s minus a, and therefore we get that value as 6 upon s replaced by s minus a, we get s minus a raised to 4 as the required answer. Option A is the correct answer. Some more I will discuss in my second part of MCQs on Laplace transform. If you are watching my videos, please like and share it, as well as subscribe to my channel to get new videos or the updates of new videos. Thank you very much.